Hello students, in this video let us solve inverse Laplace transform using convolution theorem. So first let us understand what is convolution, then we'll see what is convolution theorem, and let's solve some problems based on this. The convolution of two functions f of t and g of t is denoted by f of t star g of t and is defined by integral 0 to t f of u g of t minus u du. So this is called convolution of two functions f of t and g of t. Also we note that f of t star g of t is also can be written as g of t star f of t. Means you can also write integral 0 to t g of u f of t minus u du. From this you will come to know star operation star is a commutative. So let's see what is convolution theorem. It states that if L inverse of f of s is equal to f of t and L inverse of g of s is equal to g of t, then inverse Laplace transform of f of s into g of s is equal to convolution of two function f of t star g of t, that is defined by integral 0 to t f of u g of t minus u du. It helps a lot when you are solving the inverse Laplace transform of the function, especially when you have the product of two function as f of s. So let's solve the problem to understand how to apply convolution theorem to solve inverse Laplace transform. We have the problem here. We have find inverse Laplace transform of the function 1 by s into s square plus a square. So inverse Laplace transform of the function using convolution theorem. So given function we have to consider always the f of s into g of s. F of s into g of s. So therefore we have to split the given complete s term to be product of two s term. So we split first denominator. We have here s into s square plus a square. Let us separate s in the one function, s square plus a square in the other function, and also we have 1 in the numerator, so you can write 1 in the numerator in both. So f of s is 1 by s, g of s is 1 over s square plus a square. So product will be the given problem. Now let us obtain what is f of t. It is inverse Laplace transform of f of s. F of t is inverse Laplace transform of f of s. G of t is inverse Laplace transform of g of s. So 1 by s inverse Laplace transform is 1. Then we have here 1 over s square plus a square. Inverse Laplace transform of this will be sin a t by a. So because we have the numerator is 1, we need to multiply a, divide by a. Next, what is the convolution theorem states? L inverse of f of s into g of s is integral 0 to t f of u g of t minus u du. So the given is f of s into g of s, that is written 1 over s into s square plus a square L inverse is equal to 0 to t integration f of u. Since f of t is 1, so f of u will become also 1. Then g of t minus u. In our g of t function, we replace t to t minus u. So it will be sin at minus au. Divide by a, keeping as it is du. Next, we integrate this with respect to u. So integrating with respect to u, integration of sin is what? Minus cos. So you can do like this. Integration of, I'll take 1 by a, separate this one a out. Then integration of sin is minus cos at minus au and divide by what? So integration of sin ax is cos ax minus cos ax by a. So divide by coefficient of a. Here since we are integrating with respect to u, we have to take divide by minus a. So like this we have to integrate. Then this minus gets cancelled. These a combined can be written as a square in the denominator, and we have cos at minus au. Then we apply the limit 0 to 1. So 1 by a square, when you apply the limit u is 1, so at minus at becomes 0. When you apply the limit, angle of cosine becomes 0. So cos 0 is 1 minus, you are applying lower limit, u is 0. Then we get cos at. So 1 minus cos at. So our inverse Laplace transform using convolution theorem of 1 by s into s square plus a square is 1 by a square into 1 minus cos at. Let's solve another example by convolution theorem. So we have the problem here, s divided by s square plus a square. So you have to find inverse Laplace transform of s divided by s square plus a square whole square. So firstly we have to consider the given is product of two functions like this. Then we separate what is f of s and what is g of s. So here taken f of s is 1 divided by s square plus a square and g of s is s divided by s square plus a square. So product gives our given problem s divided by s square plus a square whole square. Next we find f of t. So that is what inverse Laplace transform of f of s. So we have here 1 divided by s square plus a square. So denominator is s square plus a square, numerator is not having any term, so you can multiply a divide by a, we get it is sin at. This is inverse Laplace transform of a divided by s square plus a square is a sin at divided by a. Next g of t, inverse Laplace transform of s divided by s square plus a square, it is cos at. Now we start using theorem to find the inverse Laplace transform. Okay, what is the theorem first? So inverse Laplace transform of f of s into g of s can be written as integral 0 to t f of u g of t minus u du. So what we have to do? In f of t we have to replace t is u. In g of t we have to replace t is t minus u. So therefore we get integral 0 to t sin au by a into cos at minus au du. Now this is in the form of sin a into cos b. We can't integrate directly, we have to apply the formula, transformation formula. It is 1 by 2 times sin a plus b plus sin a minus b. So this is what is the a term here. So where a is au, b is at minus au. So therefore you can write 1 by 2a. So this a is taken out and because of formula 1 by 2. So then integral 0 to t, we are writing sin a plus b, that gives sin at, au plus at minus au. Minus au plus au gets cancelled. Next sin of a minus b. Sin of a minus b gives us au plus au, it become 2au minus at. So we write a b is au minus b minus at plus au, it become minus of 18 minus au. So then we integrate with respect to u. Now you should be careful because we have sin at to integrate with respect to u. Then it is considered constant. So integration of constant with respect to u is ku. So therefore sin at is a constant keeping as it is. We write the result of integration as sin at keeping as it is into u. Then integration of sin is minus cos of 2au minus at and divide by coefficient of u is 2a. Then apply the limit 0 to t. Next, substituting upper limit u is t, we get t sin at. So here substituting t is 2u. So t sin 80 we get. Here if you substitute t, u is t, we get 2at minus 80, it is 80. So then we get the result minus cos 80 by 2a. Now when you substitute lower limit, u is 0 in this term, u is 0 here, it becomes 0 completely. Next I'll move to the next term, u is 0, it becomes cos of minus 80. Cos of minus theta is cos theta. So, but this minus become plus when you are applying the lower limit. So, we get plus cos 80 divided by 2a. Now, these two terms gets cancelled. Finally, our result would be t sin 80 divided by 2a. Let's solve another important example by convolution theorem. So, we have to evaluate inverse Laplace transform of 1 over s minus 1 into s square plus 1 using convolution theorem. Using convolution theorem. So, first how do we start? Given s, always this is product of two functions. Therefore, we have to separate this. What is f of s and what is g of s. First let us split the denominator. So let me take 1 over s minus 1 to the f of s and 1 over s square plus 1 to the g of s. Okay. Now you can write what is f of t. It is inverse Laplace transform of f of s. So that is what e power t. 1 by s minus 1. Then what is g of t? This is inverse Laplace transform of 1 by s square plus 1. So that is sin t. Sin t. Now we have the result. Convolution theorem is given by inverse Laplace transform of f of s into g of s is integral 0 to t f of u g of t minus u du. So, here the given is 1 by s minus 1 into s square plus 1 to find the inverse Laplace transform. So, according to the theorem, f of u means e power u, g of t minus u means sin of t minus u. Next, we have to integrate this. For integration, we use the standard formula, that is what? Integral e power ax sin bx plus c dx. So what is this? It is e power ax divided by a square plus b square sin a into sin bx plus b, bx plus c minus b into cos bx plus c. So following this formula, we find e power u where a is 1, b is minus 1, coefficient of u in exponential and trigonometric. So e power u divided by 1 plus 1 to a1 sin t minus u, then minus b become plus 1 cos of t minus u. So then we apply the limit 0 to t. So applying upper limit, we get e power t by 2, and applying upper limit here, we get t minus t 0. Here t minus t 0, sin 0 is 0, cos 0 is 1. So we'll get the result is 1 because sin 0, 0. Applying lower limit, we take minus. Substituting u is 0, we get minus sin t, and substituting u is 0 in the last part, we get minus cos t. Minus because you are applying lower limit. So this is the result by convolution theorem.